But why don't we start by just having you guys give us an overview of the robot and the different systems.
On the top side of the robot, we have dual intake arms. They're perfectly identical and symmetrical. So, if we want to use either side of the robot strategically, we can. On the field, what that translates to is the ability to manipulate the ball from basically any band within 180 degrees. Um, the flywheels, as people have been calling it, the wheels will spin at around 60 miles an hour to launch the ball from a static state, or we could start spinning at 60 miles an hour and smack the ball and launch it further away from us. And that allows us to pretty chaotically control the flow of the match, as everyone's seeing. Aside from the intakes, the arms are being driven by Repeat Robotics Repeat Drive Max V2 motors and in position control mode. And using that, we're able to get a lot of varying set points instead of just full up or full down. So we have a middling set point that allows us to herd the ball into a more favorable position, or a down set point. We call this vert mode, which allows us to launch the ball at a sort of a long-range shooting angle. But I think the most defining feature of the robot is the swerve drive hidden underneath, and I'll speak to that.
Yeah, so we basically figured that it'd be beneficial to be both fast and be versatile and being able to move in any direction. So the classic FRC alumni, FRC mentor mentality, we went with the swerve drive. And we have a bunch of different control modes that we've been trying out in different matches, just depending on how we're going. So there's classic where the front of the robot is forward always. Then we have like a field-centric mode where it uses an angle on the robot so that no matter what, when we press forward on the joystick, the robot moves forward relative to the field. And then we also have a few other interesting modes. Like one of them is where it's closed loop in the heading and relative to the field. And whichever direction we push the orientation joystick in, it points the rollers. So this is beneficial, or it points the robot. So this is beneficial for like really trying to do smackdowns or vert mode. It locks the robot in forward orientation relative to the field while still maintaining the field-oriented control. So as driving the base, the robot handles all the yaw control on its own, and then the field-oriented mode just kind of moves in the correct direction that I tell it all the time.
Interesting. Yeah, it seems like you guys have gotten better and better throughout the day of controlling the match and getting some of those shots across the field. A few times you were able to pop the ball up over another robot. Is that something that you designed for, to do those kind of chip shots?
Yeah, like in pretty early testing, we saw that the robot was capable of that, but it's more a matter of getting the correct, the right chain of events where it's possible. Because when the ball's moving fast, it's hard to chase it down.
Yeah.
Right.
So this robot was designed a little bit differently from a strategic standpoint than most of our FRC robots. At the U.S. National Yo-Yo Contest, Alex and I got to talking and realized that I wanted to build a robot for Rival, and he wanted to build a robot, and his swerve drive already existed. So the upper structure was designed more, the design was driven more of a volume constraint based on the existing swerve drive. So we had a couple of different ideas for mechanisms, but by creating a dual-sided intake system, we figured we can get the most strategic flexibility out of that, and any specific functionality, maneuvers, the chip shots, the smackdown, the vert mode, we would find those through practice and testing rather than designing them in specifically.
Yeah, that makes sense. I do want to talk more about the swerve drive because it's one of the coolest things I've seen in a long time.
So this is like a pretty meta FRC style coaxial swerve drive. So both of the motors are grounded, meaning they're not pivoting with the module, and so all the wheel rotation is handled through these bevel gears, which are offset just for compactness. And it's mostly custom based on sizing and the motor selection. We weren't going to necessarily use the FRC motors; they're difficult to fit in this form factor. And I didn't have them, so it's a bigger constraint.
Because Rival is so new and refreshing, we didn't have a good grasp on the sort of power scales that everyone would be observing. We knew that SSDs were going to be really popular here because they're a turnkey kit that plays the game pretty well. We knew that there would be a lot of Vex EDR kits and a fair number of custom solutions, but drive motor power was not something we had a really good pin on early on in the design process.
How much power is in the drive?
It's about 400 watts per.
Okay. So a Vex motor is about 11 watts. So this,
And yeah, that being said, it's not actually putting that 400 watts into
Right.
the ground, and it's
Yeah.
limited in software mostly. But yeah,
but that gives at least a sense. In person, it's really violent when this thing hits the wall, compared to something like a Vex robot. What control architecture are you running?
so all the wheels are running. The wheel motors are running closed loop velocity control at about 20 kilohertz, and then the pivot motors and arm motors are running closed loop position control. And so the arm motors and the pivot motors are running the same motor controllers as custom firmware.
What are the motor controllers and motor setup?
They're brushless outrunners,
Okay.
and then field-oriented control motor controllers based off of the Mini Cheetah. A lot of the electrical components and like the robot infrastructure is based off of Mini Cheetah, and not just because that's something.
So
Right.
from a transmitter receiver perspective, Impact is basically two robots in a trench coat. On the top side, all of the systems are controlled by standard RC receivers, RC equipment, and I do all of the control mixing on my radio. And on Alex's side, he has a custom microcontroller that translates all of the RC inputs into the swerve drive commands for angle, heading, and the orchestration between all four modules.
That does seem to be one of the more difficult parts of building a robot like this. There's only one other robot here that's attempting to do something similar using O-drive controllers, but generally in like combat robotics, you don't have to think about your control architecture. You just have a simple RC setup. Like in first, you also don't really have to think about that stuff. The control architecture is solved for you. Same thing in Vex. How do you see that playing into something like Rival?
I think Rival, with its open build setup and lack of restrictions on the control system, allows teams a lot of freedom in designing their own control system however they want it. At least for us, when I was laying out the controls on the top side, I wanted something that I was very familiar with, that was very simple, that I could personally debug very quickly, while Alex's side on the swerve required a lot of fine control over how all the outputs are being controlled. So he's leaning on a lot of existing technology he's developed in the past for other projects for microcontroller there. I think with an environment as open as Rival, it's certainly going to be a challenge for teams to sort of sift through all of the different options and control setups, but it will open the doors up to do some really, really cool control setups for the robots going forward.
Yeah. So for example, if you wanted to do vision, it'd be pretty hard to do that with an RC radio alone. But the RC radio is able to get people who are familiar with it off the ground faster than dealing with all the infrastructure, headache that the more complicated solutions have. So having the openness to different control systems is useful for getting more people off the ground.
Yeah, I mean this is a real robot. This is a robot. A lot of the battle bots, it's not a bad thing, but they are like giant, overpowered RC cars in a way, and that was definitely something that I was inspired to start Rival, to see more advanced competitive robotics outside of those things. And so it was like a dream come true when you guys dropped your reveal video. I knew you were cooking up something, but I was going crazy. I was so happy. I really look forward to seeing several of a robot of this caliber on a field, getting more FRC mentors and other BattleBots people involved.
I just wanted to touch on this really quick. In the chaos of match play, our robot didn't walk away unscathed. Because of the volume constraints on our robot, this is what we call the bad side. It's all scratched up, missing letters. that's supposed to say impact, but the biggest damage that we saw today was, I believe we ran into one of the corners on the field, and this entire side dented in and jammed up one of the swerve modules. We were eventually able to clear it on the field, but pulling the structure off of the robot to get that dent repaired and dealt with after the match was definitely a little bit stressful. But the fact that these robots can weigh up to 25 pounds and have 1600 watts of drive power can really really makes the game a lot more dynamic than if everyone was limited to 11-watt modems, right? So I think the way that the rules are set up and the game is designed, I think it makes for some really exciting match play, and I'm excited to see what other teams can bring too.
How much of this robot is custom? I don't think we talked about the manufacturing.
Basically, every part of
Yeah.
it is custom in a way. Like even the wheels, they're Baneбот's wheels, but in order to attach the bevel gear for the swerve, we had to modify them. And,
So it looks like all sheet metal exterior, and then some
made by one of our competitors.
Team Fabworks.
Yep.
Yeah, and then some CNC stuff for the swerve.
Modules, yeah.
And then how
3D
did
printed parts.
are these printed?
Yep.
These the arms.
So the intake arms are entirely 3D printed out of nylon on a bamboo printer. The arms themselves are their own self-contained unit. The pulley that drives them is integrated into the arm. The wiring and speed controller is hidden inside of the arm, and the motor is right here. So if we wanted to, we could pull the arm off, unplug it, and service it in time for the next match. But we wanted to be able to use a lot of different manufacturing processes as well, because we're both active first mentors, and I really believe in sharpening the saw and gaining new skills and figuring out how to better apply technologies here so that we can bring them to our students and they can apply their technologies there, and it's just a continuous cycle of learning and improvement. So by using a lot of these, integrating a lot of these different processes into the same robot, outsourced sheet metal, 3D printing, CNC router at home, we're able to create a robot that is a good learning exercise for both of us, and a good example to draw from in case we want to reference these sort of design techniques in the future.
That's really interesting. That's something that I considered when I was starting Rival, is that I feel like competition is kind of the best way to develop new technology. Like competition is how our whole economy works. When you have teams of really talented, smart people trying to solve problems, and I think I've seen student FRC teams do more impressive work in 6 weeks than some of the engineering teams I've been involved with in my career. There's something about the time constraint, the problem constraints, the way that the game is structured, that yeah. And so I'm really excited to see what technology comes out of something like this, where certain parts of this robot, like navigating a 3D environment, you're not using the tags yet, but using vision, using sensors, having precise control of the position of the robot, the different control modes you talked about. These are all things that have wide application across, any industry, really. Formula One teams have over the years developed like hybrid technology and other automotive technologies that make their way out into industry. And so what you were saying just kind of reminded me of that.
Yeah, so we had a lot of fun during the build process, and I think through participating here, it's going to have some far-reaching effects on the project that we work on in the future, the projects that our teams work on in the future, through domains in FRC, combat robotics, Rival, professional, actual, real robot engineering. So it's been a really good experience, and I'm glad we've been able to be a part of it.
Awesome. Thanks you guys so much. It's really good to have you here.
If we can, I would like to shout out our sponsor,
Yeah.
Repeat Robotics. Repeat Robotics produces quality insect weight up to hobby weight combat robot parts, and they power our arms. So just wanted to give them a quick shout. Thanks, Peter.
Thanks, guys.
Yeah.